Because most classes that I know of, use code blocks for C and C++. Not that it's the only thing that works. But. All right. Oh, projector. There we go. All right, turn on projector.
So should we download code blocks right now?
All of these computers have code blocks already installed, but when you're home, I think you might need to get it downloaded and installed because, well, it's free for one thing. But my assumption was incorrect because I thought everybody used code blocks. So it's close enough. I mean,
Yeah.
It's Windows, which is not what I want. All right. Okay, so for the first part of this today's lab, I'm just going to demonstrate how to set up everything because this is one of the few actual C programming project. The idea is for you to really get some hands-on experience with floating point numbers, and that's the purpose. So I need to kind of set up I need to show you guys how to set up everything. First of all, how many people did not use code blocks in C and C++? And had no otherwise had no exposure to C++. Okay, that's fine. So the first thing I would just kind of show you guys how to get code blocks. Code blocks is a open sourced IDE or integrated development environment for C and C++ programs. So you just go to, just search for code blocks, okay, in Google or some other search engine. The first link, code::blocks, is the actual website. Once you get there, I think the rest you can probably figure out, just go to the downloads link. And I believe it is available for all available platforms, which means you can download the binary release. Unless you want to mess around with the source code of code blocks itself. Most people usually do not want to do that. So you have Windows, we have Mac OS X, and we also have Linux. So unless you're using some weird operating system like FreeBSD or something like that, you should be covered. And it's free of charge, okay, so there's no need to pay anything for this. So are there any questions about how and where to get code blocks installed on your computer? All the computers in the BCS area should have code blocks installed already, so you should be able to get the project started today. For those of you who prefer not to use any IDE and you just say, I know how to use the command line GCC and G++, commands, that's fine too, because the source files are provided and you can definitely do it without an IDE. All right, so any questions before we move on to the second part of what you need to do for today's lab? Questions? All right. So if there are no questions, I am going to go back to today's lab's description. And I spent quite a bit of time to think about what to do with this lab, and I think this is going to be beneficial. All right. So the question, there's only one single question, but to answer the question, you really need to write the program. Without writing the program, even if you combine all the skills and all the math that you have learned in the previous two labs, that would not be sufficient. You wouldn't be able to get the correct answer. Because the correct answer requires 64-bit math, and most calculators, including spreadsheets and whatnot, they actually do not use 64-bit math when you say log and stuff like that. Okay, so this is the description of your homework assignment. So there's instruction, copy quote unquote this file, which is a hyperlink. So when you right click on this hyperlink, I'm hoping you're in Canvas right now, but if you're gonna hyperlink, if you right click on this one and open a new tab, that will bring you to a particular spreadsheet that is really simple. It looks just like that. Okay. There are only two things you need to do in this particular spreadsheet. Let me magnify first so I can show you what it looks like. All right, so on column A, row 2, there's a place for you to enter your 7-digit student ID. So this way, the problem set is slightly different for every person. Okay. So for instance, you cannot change this because this document belongs to me, and you only have read access to it. So what you need to do is to copy it. Okay. Do not move it into your own Google Drive. You have to make a copy of this into your own Google Drive. Do you guys know how to do that?
I guess.
I think it's under File, and it says, okay, on mine it says you make a copy. Do you see make a copy on yours? That. Okay, make a copy. It will make a copy on your own Google Drive based on what account you sign in, but it's assuming you're using the same browser that you're using Canvas. It's going to be the Los Rios apps.losrios.edu Google document site. So what you need to do is to do not move, use, make a copy, okay? So make a copy into your own folder. Once you do that, you'll be able to edit the spreadsheet. So what you do is you go to the cell that is in blue, okay, and then enter your actual student ID. I just picked some random student ID. There's a really, really slight chance that it actually matches somebody's ID in this class. But let's say your actual ID is 131. Okay. How come I cannot edit it? Okay, so 131. 2540. Okay, so let's say this is the new ID. So once you press the enter key on your copy, you will see the Mantissa 10 to change, Exponent 10 will also change as well, and also the number that you need to test will change as well. Okay, you don't need to pay attention to column C or column D. That's not for you. It's just some temporary calculation that I need to do. But what you do need to do is to copy the string or the characters on column E, which is 3.457, E minus 10 in this case. That would be your test string. Is that okay? Does everybody know how to generate your own test case? Now, if you really want to test your program and you say, I want to test my program on other strings too, that's fine, okay? And I'll show you how to test your program with other strings. So is this part okay? How to generate the test case for your specific ID. All right? Okay. So when this is all done, then we go back to the question and continue to read. There's another hyperlink here. This is an archive of the code blocks project that you can start with. So assuming that you already have code blocks installed, okay, what you do is you right click, or you can just click on this one, and it will bring you to a document on my Google Drive. So this time you want to download it, okay? Do not make a copy. If you want to make a copy, that's fine too, but I would just download it, which is using this link here. So you click download, and typically, unless you change your browser, it will be downloaded to your downloads folder, which is fine, okay? You can open it right away, but I would just save the file so that you have a copy first. So you would just save the file to your downloads folder or wherever you want to save it. Okay, I'm gonna put it into my downloads folder. Click save, and now I have the zip file saved. In Windows, when you download the zip file, your browser will automatically ask you, do you want to open it, and you can unzip it at that time. Does anyone need instructions in Windows to unzip a zip file? Good. Because I was about to send people to cisp310, where they start with the power button on the computer. Press this to turn on your computer. And then it will proceed like 2 classes later to differentiate what is the right versus the left button on the mouse. I'm glad that I do not have to send anyone back to that class. Okay, so assuming you got the zip file already done, so you will unzip it. Okay, so I'm going to do it just like you do, okay, just like you're supposed to do. So let me go to okay, there we go. Now, because I'm old school and I do not use graphical interface as much as I want to, so I go to the folder. Okay, you can unzip it right here. I'm just gonna show you what files are inside the folder. So it's called double1.zip. So once you unfold it, it will create a folder. It will create a folder called double1 itself, and in it you will find all of these files. I know there's a lot of files, but you don't have to worry. Okay. Your job is only to write one single function. It's already, the shell itself is already set up. I just have to show you how to get into the project, get to the part that you can work on. Do we have any questions at this point? Okay, no questions. So assuming there are no questions, if you do, just raise your hand and let me know. I already have code blocks already installed. So the way you get to code blocks in Windows obviously is going to be slightly different depending on the operating system. And this one already has a project open. So let me close that first. So this way I can show you exactly what yours would look like. Okay. All right. All right. So when you first start code blocks, you will see something like that. The version number may not be identical, and then there are a few other things that may not be the same, like you may not see Linux over here if you're using the Windows version. But the rest is about the same. You go to File, assuming you remember where you unzip the file, you say File, and then go to Open. And then you just navigate to wherever you unzip the file. In my case, I unzipped it in my Downloads folder, which is here, into the doubles1 folder. And in here, there's one particular file that you have to open. It's the CBP file. So there are several files here with double1 as the name, but they all have slightly different extensions. The one that ends with CBP, Code Blocks Project, is the one that you need to double click and open. If you cannot see the extension, because Windows by default is now hiding extensions, you can see the one that has an icon. That's the one that you need to open. Is that okay? All right, so let's open this file. Let me open this file. And it shows you the project itself. So main is already written, okay? Main does make use of ARGV and ARGC, so it's not a very simple type of main, but you don't have to mess around with it. Just leave it alone, okay? You can also go to the project view and just do one single click on sources. There are 3 source files because I like to separate files into different folders. I like to separate my functions into different files depending on what they do. Main, there's not much you have to do. There's parse. So if you want to look into my code of how to parse the base 10 scientific notation, you can read that, okay? Because I wrote the code to do exactly that. But if you're short on time and you don't want to do something that you don't actually have to do, just skip parse.c. You can go straight to exp1022. This is the one file that contains a function that you need to actually complete. So when you double click on that file, you will see there's one function where the body is empty. And that's what you need to do here. So what you need to do is to write the code to convert a base 10 scientific notation number into a base 2 scientific notation number. But you don't have to go all the way to a double, okay? That's kind of lengthy and difficult. This is just one step. I'll show you which step we are talking about here. But before we go there, I need to show you how to debug your program. Okay, how do you give it a test case, and how do you stop to see whether your program is working or not? Yes?
Is this all due by the end of the lab?
No.
Okay.
If you open the lab itself, you would see that it's due in a week.
Okay. All right. Sorry.
Okay, so it's due in a week. It's not as much time as you think it is because we have exam 1 on Thursday. So, but we do have lab on Thursday. So yeah. Okay, so anyway, let's see how you can debug this program. So the first thing you need to do is to go to Project, and then you go to Set Programs Arguments. Okay, so once you get there, debug is fine. Okay, I don't think you need to worry about the release version. So keep this tab in Debug, and then in Program Arguments, what you do is you specify this -n. Okay, your -n, a space. And then whatever scientific notation you want your program to work with. Okay? Your program is, at this stage is only supposed to work with numbers with a negative exponent of 10. So that's all you need to worry about. Okay? So if I want to test it like with something simple, I can just say 2.5 e minus 1. Okay, I just mistyped something. E minus 1, like that. So 2.5 e minus 1 is representing 2.5 times 10 to the power of -1, which is a quarter. Yep.
How did you get to that?
You go to Project, and then there's a Set Programs Arguments option. Can you find it? Okay. This is all getting recorded. Okay, it's all getting recorded. If you cannot follow the steps or you do not have it installed yet, huh?
Is the audio on? Yeah, the audio.
Yes, the audio is on. I checked. Yep, it's there. Well, it's recording something audio. I'm not sure what exactly it is recording. Okay, so are we good at this point? Okay, so you just click OK. Okay, and you're now almost all set up. So the key is by the time I get to line 11 at this point, which is the end of this particular subroutine, whatever PM points to is a structure. And in the structure, there are 3 members. One member is mantissa, one member is exponent 10, and the other member is exponent 2. Okay? So your job is to change that representation so that the value that you're representing does not change, but you would have 0 for exp10. So let me show you what I mean by that. So first of all, it would be really helpful to set up a breakpoint here. To set up a breakpoint, you just put your pointer on the right, just a little bit to the right of a line number, and then just click it. Okay, when you see this little stop sign symbol, it means it has set up a breakpoint. You can set up as many breakpoints as you want as you debug your program. My version of this code is about, I would say about 8 lines. Okay, so this is not supposed to be a very long program once you understand the concept. So I just set up a breakpoint here. And to debug the program, you go to Debug, and you just say Run or Start/Continue. Okay, so this will trigger the compiling of the program, as well as it will run to the first point where you can stop. So I'm going to click here, and you will see the messages down here saying la 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 la. Okay, and right now you can see that inside the stop sign, there's a yellow triangle. The yellow triangle is telling you where the execution point is or which line is about to execute. Okay, whatever line that is pointed to by the yellow pointer has not executed yet. Now that is important if you're trying to single step through your program, is to remember, if you see the arrow, that line is about to execute. So right now, obviously this function is not doing a single thing. All right? The other thing that you might want to also observe and pay attention to is at the bottom of the screen here, inside the debugger pane, okay, you can see that it allows you to enter commands and do all kinds of stuff. Let me pull this up a little bit. Now, obviously, you guys have expensive and nice computers compared to mine, and you won't have this problem of not being able to see enough of the screen. But the thing is, there's a command prompt here all the way to the bottom. Okay, some of you may or may not be able to see it because you're in the back. Let me see if I can always resize the screen to make it appear. There we go. Okay, now do you see it?
Yeah.
all the way down here. All the GDB commands you can put here in order to do, you can do everything that you can do in GDB by using this command here. You can also use the GUI tool, right click on the variable and then say watch variable or watch expression. That works too. I personally just prefer to enter the commands here. So you can enter something that's silly, okay? Okay, you can say print 121. And guess what it's gonna do? Print 121. But everything that I do in class using the command line version of GDB, you can do it here as well. So that means you can do all the tricks that I can do in class. But in this case, what I'm really interested in is what is Pn pointing to. Pn is my parameter here. So I want to know what kind of structure it is pointing to, what are the values of that particular structure. So right now I can see that the sign is 0 because the number is non-negative. The mantissa is 25, not 2.5, because remember, in the class I already emphasized that I want to use only integer arithmetics to convert from base 10 to base 2. So that's why it is not representing 2.5, it is only representing 25. However, that 0.5 is taken care of by decrementing exp10 or the exponent of 10 by another 1. So you can remember that the string that I entered is e minus 1, which means times 10 to the power of negative 1. But because I shift that decimal point from between the 2 and the 5 to the right-hand side of the 5, I'm decrementing the exponent of 10 one more time, so that we are multiplying by 10 to the power of negative 2. So it is still representing the same value. Okay, the value that it is representing has not changed. Are we doing okay so far? As far as the framework of what you need to do, what kind of tools you need in order to write a program. Is that part okay? All right?
How did you get the arrow inside of the stop sign again?
You have to start running the program. In other words, you have to go to debug and then click start. Okay? Once you're at a breakpoint, you can click this to continue execution as well.
Okay.
But that's assuming you're already at a breakpoint. Okay. So what is the correct answer? Okay, in this particular case, once you get rid of exp10, in other words, I want exp10 to be 0. Okay, and the only way you can do that, and I want mantissa to be as large as we possibly can. So I want mantissa to be somewhere between 2 to the power of 63 and 2 to the power of 64 minus 1. So you cannot just give me something that works. You have to actually make it fit that particular format. One of our quizzes, I think it's the previous one, actually has some problems related to that. So you might want to kind of remind yourself, what we did. But this time you have to do it by code. Okay. So in this case, the mantissa is going to be some really gigantic number, and then you will also see exp10 to be a 0, and then exp2 would be a pretty large or pretty negative value to make up for that. Yes?
Is that the mantissa that's 2 to the 63 and 2 to the 64 minus 1?
It's the mantissa that is between 2 to the power of 63 and 2 to the power of 64 minus 1. In other words, okay, I can describe it in fewer words. The mantissa must have the most significant bit being a 1. It is an unsigned integer, but the most significant bit has to be a 1. Because this will set us up to be ready to normalize the mantissa and turn it into an actual double representation. So is that question answered okay or not? So does everybody know what you need to do? So you can probably imagine that your question, is a little bit harder to do it by hand. The question doesn't, I cannot tell whether you're doing it by hand or whether you wrote a program to do it. But to do it by hand, it is almost impossible. Because I tried all the scientific calculators, the spreadsheets, they all cannot maintain the precision of 64 bits as a number. Okay, they can represent values just fine, just not the precision. Okay, so whatever you end up with here has to be of the right precision. That number has to be exact. Cannot be off. So are we doing okay so far? So how do we do this? In other words, how do we, first of all, how do we make Mantissa as large as possible, but not overflowing a 64-bit unsigned integer? That's the first thing you need to do. Yep.
Log 2 of the large number minus your number.
You cannot use log because that's a floating point number calculation. So you can only use integer arithmetics to do this. But instead of using a closed form equation, you can use a loop to do it. Efficiency is not the biggest concern here, but you do have to use all integer arithmetics to do it. Yep.
Could you just loop and continually like multiply by 2 and subtract 1 from exponent 2?
You can keep multiplying, okay? In fact, you have to keep multiplying by 2 or keep shifting to the left, but you have to remember how to test to know when to get out of the loop. Yes?
I don't think this is going to come into play, but is there a language standard which we're not, like, can we use C++ 2017 or do we have to stick to 98?
Say that one more time.
Language standard. Do we have to stick to 98? C++?
No, as long as GCC can handle it.
Okay, cool.
Yep, and I think GCC, the latest version of GCC is pretty. Yep.
So like, why can't you just keep multiplying by 2 or bit shifting to multiply by 2 and then at the end do that weird like command trick to check that it's in the range?
That's one way to do it. So I'll leave it up to you guys to figure it out, okay? So each person has to work on this one, to kind of figure it out. And then the second thing is once you get it that large, it's time to divide it by 10, right? Because the whole idea is to divide the Mantissa by 10 and then increment exp10 by 1 so that eventually it will become 0, okay? But you have to remember, we talked about this in class as well, when you divide using integer division, you're going to lose something. It is always truncated, which means the result of the subtraction is always smaller than what it is supposed to be. So you need to use the rounding trick to make sure that you do not have a bias so that the number is always smaller and smaller and smaller. When I check your answer, I'm going to check it against the output of my algorithm, which takes rounding into consideration. So if you're not doing rounding, I can tell, and then you're not going to get the credit. Is that okay? All right, but we do have time, okay? So you can use the rest of today's lab at least to kind of get familiarized with the environment and also the question itself. Yep.
Are we updating the H file too for the?
Are you updating the what?
Are we updating the .h file too?
You do not need to. I don't think the .h file, is of any consequence to you. One more thing you can do, I don't think it is needed. Okay, let me pull this back down a little bit here. Okay, so one more thing you can do is you can create as many subroutines of your own as you need in this particular file. So you can modularize your code and create additional subroutines if you need to. But the point is, okay, no pun intended. The point is you cannot use floating points in your own calculations. So you cannot use double, you cannot use float, you cannot pound include math.h or anything like that. Okay, you have to only rely on integer arithmetics. So multiplication, division, addition, subtraction, comparison, but all only using integers. Shifting too. Okay, I almost forgot shifting. So are there any questions about the homework assignment? What you need to do? No? Okay, yep.
For code blocks, I can't find, well, it's not finding a debugger or a compiler. Just trying to find those.
You have to download the full version of code blocks. Okay, that's a good question. Let
Are
me
you
go
on a
back.
Mac?
No, he's.
Okay, mine said the same thing too.
That's because you may not be downloading the version that I want you guys to download. Okay, so getting back to that question. Okay, so when you go to download, let's take a look at all the options here. There are several options in Windows. So there's the setup file, main GW, no setup. So you want to get the main GW setup because that includes the libraries, the GCC and stuff like that. The other one, which is just the setup file, does not include that.
What about for the Mac?
Huh?
I think it's only one.
The Mac may not be the same because the Mac I think comes with its own C compiler, or you can download and install its own C compiler. But let me just kind of read this part here.
Okay.
The second note here, okay, the second note says right here, the main GW setup includes additionally the GCC/G++ compiler and Gdb debugger, and that's why you have to get the main GW version and not just the regular setup. Is that okay? For PCs, for Windows, make sure that you download and install the one that has main GW setup. That's the one that you need. Okay, so let me move on to Linux. Not Linux, but Mac OS. All right, so Mac OS has its own notes here. It's currently not available.
I just read that.
due
I
to
just
the
read
lack
it.
of. Okay.
Just need to go down. Use my roommate's computer, I guess. Do my homework again.
It's because the Mac users don't use it that much.
Yeah, I'm not like that. It does have a file. It's just not the latest version, I think.
It's a zip file, maybe it's
We
everything
want to
inside
get people to
it.
make it.
Yeah, so it still has a file. It is code blocks 13 instead of code blocks 17. So I think you can still get it. It's just that this is an older version. For what we do, it is not gonna matter all that much because we are not getting to the cutting edge stuff.
Okay.
Sorry?
Use C-Line if you're on the Mac. It's a jet runs at
What
it's free if you're a student.
Okay.
Just a suggestion.
Okay, sure. That works. Any other questions? For those of you who want to just get down to the command line interface and don't want to do anything with the GUI, you can do that too. Okay, so in case you're one of those people, you can run GCC by itself. There's no need to use G++ because I only use regular C instead of C++ code. So just GCC -G is required for debug information. -warn all is optional, but I highly recommend it. -C, which means we're compiling to only object files, which is kind of optional too, but I typically want to separate the two process. And then you can just give it the source file that you're compiling, like parse.c. You can also compile multiple source files at the same time, so you can give it main.c and also the one that you need to write, which is exp1022.c. And then press the enter key. This will only do the compiling. In other words, it does not give you an executable. So you have to say GCC-O, and then give your executable a name, like main. And then you have to specify all the object files that you're linking. Did you guys know what is linking? How many people can differentiate between the compiling process versus the linking process? 2.5. Okay. So the first command, is going to do the compiling. The second one is going to do the linking. The linking process is necessary when you're dealing with multiple file projects. So now that we have everything done, then you can just use a GDB on main, and then you can do all the same tricks that I usually do in class. Set up with a breakpoint, execute at a certain point, print whatever you need, and so on. Are there any questions about this? If you are taking one other class that's using the power server, you can do this on the power server as well. Okay, that's fine. Yep.
Oh, we only have to do this if we're using a terminal?
Sorry?
We only have to do this if we're using like a power server or something?
If you want to do on a power server, you have to have a power server account already, which means you're probably taking one of the other classes that makes use of the power server. Then you can just set up a folder. You can upload the zip file to the power server and then unzip it. You can also unzip on the Windows side and then use WinSCP to copy the whole folder over.
Okay.
So you got a few options there. Any other questions about how to get a project started? Yep.
The argument and like the number structure that we're going to be working with this program. I'm just curious if there's any other way to change what that is other than going into the options and changing the argument.
If you use code blocks, that's the only way to do it, unfortunately. So the idea of code blocks is it simplifies the whole process.
Right.
So when you want to change your test case, then you have no choice but to go to project and then go to set programs arguments and then change this number to whatever you want to debug it. Because I'm using the argument of the command line to pass the string in to process instead of using standard in. So this entire program doesn't use standard in or standard out at all.
Okay.
It's not too bad because if you want to debug your program, you probably want to stick with the same number or the same string as the input until you get that to work. Then you might want to change it to.
Mm-hmm.
Yep.
How large an exponent do you expect us to be able to work with?
The exponent should not be getting too big. The number that you're given with has about 3 digits after the decimal point. So that means you're working with, in the worst case, you're working with up to 9,999, and then the exponent of 10 is going to be negative 23. So you can then figure it out. I mean, every 3 in base 10 is about every 10 in base 2. So 23, let's call it 8. So you might end up with something times 2 to the power of negative 80 something, maybe negative 90. But it's not going to be some insanely large number. Yep.
So like after we write our algorithm for this and we get some sort of result in Gdb that we're looking at, like the mantis and the exponent, are we just supposed to like check that against what we have in the spreadsheet to make sure it's correct, or like how do we know what we have is right?
Okay, you can send it to me. You can send it to me to test it, but here's one more thing you can do. So what you can do is go back to the homework assignment description, because in the homework description, where is it? All right, so in the homework description, this is what we're trying to preserve. This expression here, mantissa times 2 to the power of exp2 times 10 to the power of exp10 is what we're trying to preserve. The base 10 representation is pretty easy to understand, so you know what value it is representing. So you just have to enter the rather large, base 2 number as the mantissa, and then multiply 2 to the power of whatever exponent of 2 that you're dealing with, and see if it comes up with the same value.
Okay, so just check it on like a calculator or something?
Yeah, you can check it with a calculator. The mantissa is going to be one really long base 10 number, but if you're working with a computer, you can just kind of copy and paste it. Most calculators, even though it cannot internally have that much precision, it will just truncate it. So you will still get approximately whether your number is correct or not. The other thing is I would suggest you guys to use numbers that are easy to work with, like the one that I just showed you. Okay, let me show you. Let me get back to that one and explain why that's an easy one to test. Oh. Where's my code box? There we go. Okay, so the number that I chose to use is 2.5 times 10 to the power of negative 1, which is otherwise known as 0.25, right? But 0.25 is also special because it's a power of 2. It is 2 to the power of negative 2. Is that okay? So that means if I want to use a quantity that is at least 2 to the power of 63 and at the most 2 to the power of 64 minus 1 times some kind of power of 2, this one is easy to work out. Okay, let me show you why it is easy to work out and what should be the answer for this particular case, because this makes a really good test case. So let me use mousepad. Okay, there we go. So when you use mousepad, okay, so we have 2.5 times 10 to the power of negative 1, right? This is the same thing as 25 times 10 to the power of negative 2, and that's why we saw that what Pn points to is exactly that, okay? Because the mantissa only applies to the case where we have an exponent of 10 that is a negative value. Is that okay? Okay. So the answer in the end is going to be something like this, okay? I'm going to use hexadecimal because that's a much easier way to express this kind of pattern. So the answer is going to be 8 and then followed by 15 zeros. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, okay? You can print a number in hexadecimal if you do a print /x, okay? So if you print /x and then Pn points to the mantissa, this is what you should be seeing. Because that, okay, tell me again how many bits correspond to one hexadecimal digit? 4, okay? So we have 16 digits here. Hopefully I did not miscount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, way too many, huh? 1, 2, 3, 4, 5, 6. Okay, I got 4 too many digits here. Okay, does that look right to me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, so this looks right now. There are 16 digits. 8 as a hexadecimal digit corresponds to 1, 0, 0, 0, which means in this case, just the most significant bit is a 1. It's a pretty large power of 2, okay? So now the question is, how do I adjust the power of the exponent of 2 so that in the end, I'm still representing only a quarter? That is the question. To the left-hand side, the mantissa itself is 2 to the power of 63. So how do I turn 2 to the power of 63 into 2 to the power of -2? But only by adjusting the exponent for base 2.
-65?
Yep. So that would be the correct answer. If your algorithm can come up with this, okay, based on this particular input, your mantissa is 8 followed by 15 zeros in hexadecimal, and then your exp2 is -65 in base 10, then your algorithm is probably working correctly. This one does not involve any rounding, okay? So rounding does not actually has any effect over here because the values are represented exactly. Is that okay? Well, okay, a few other test cases, okay, because I want you guys to be able to kind of test your program. Can someone give me another test case that is kind of easy to figure out? Something like this, maybe not as easy.
About 1.5.
1.5 and times what? The power of 10 has to be negative, okay? So you can say 1.5 times 10 to the power of what?
-30. Or can it go to that?
Actually, if it's 0, it will still work, okay? This will still work. I'll tell you why. Because the program will automatically convert the mantissa from 1.5 to 15. But the only way to preserve the value is to decrement 1 from the power of 10. So you will still end up with a negative power of 10. So this will still work, okay? So now the question is, if I convert this whole thing into a base 2 number times the power of some, times a power of 2 to represent this value, what do you think the mantissa is going to look like? Okay, I'm rather lazy here because I don't want to count all the digits again. So copy, paste. So with this one, it's going to be a C here because a C is 1100. Because 1.5 is 3 divided by 2. Okay? So this number, C and then followed by 15 zeros, is what? If I want to express this as 3 times 2 to the power of something, what is that? It's 3 times 2 to the power of You just have to kind of, in your mind, you'll do the shifting a little bit. 61. Okay, so this is 3 times 2 to the power of 61, and I want that 61 to become -1. So what would be the exponent that I need to adjust it with? Times 2 to the power of, we know it's negative. The question is how negative. We have 61 on the left-hand side. We want it to be exactly -1.
62.
62. Okay, so how do we check this? Can we check this using a calculator? Okay. And the answer is you should be able to test it with a calculator. You can also check this, well, maybe a calculator or a spreadsheet. Okay, so I'm going to test it with a spreadsheet. So you can go use a, well, maybe not. The problem with a calculator is if you don't have a calculator that can do base conversion, this is a pretty big number that you have to specify. But the other way to specify this, okay, is to look at this and say, oh, this is really the same thing as 0x. If you want C0, okay, that's fine. But you can shift it by how many times? C0 takes care of 2 of the 16 digits. We got 14 digits left, right? But we're not going to shift it by 14 times because we have 14 hexadecimal digits. So the amount that we have to shift it with is going to be 14 times 4, which is 54. So this should still end up with the same value, which is -3. Yes, no, sort of. You guys looks like you guys are not convinced. Okay, so I'm gonna carry out this entire math here. Okay, so this is 15 times 4 because we have one more hexadecimal digit to take care of, and then this is 2 to the power 60, -62. Okay, so you can see certain things are going to cancel out because every time you do a left shift, it's the same thing as multiplying by 2. So left shifting by 60 times is the same thing as times 2 to the power of 60. Is that okay? More or less. Okay. So the 60 and the -62 will cancel out a lot, right? So then we end up with 0xc times 2 to the power of -2. That should be a -2 left over. So now we look at this and go like, it looks like TAC was wrong. We are off by 1. Because C in hexadecimal is 12. 12 times 2 to the power of -2 is 3. It is not 1.5, so I was off by 1. So the off by 1 should be adjusted over here. This should not have been -62, should have been -63 instead. But that's how you can check your answer. You know, it's not to use the more complex numbers, but to use something that's easier for you to work with. But the bottom line is you still have to be familiar with the notion of a value times 2 to the power of some power, or also with a power of 10 component in it. Are we doing okay so far, or not? Yes or no? We do okay? All right. So if you're doing okay, then I'm gonna stop the recording because I think we talked about how to set up everything already. The concept is in the notes. Okay, so if you read the modules, it actually talks about the concept of how to do this conversion. Just one more thing. Okay, so in the homework assignment, I describe exactly what the restrictions are. So the restrictions are, the mantissa should add up as a value that has bit 63 set. Okay, so that's an easy way to describe it. EXP10, which is a member, should be a 0. exp2 can be any integer, but it is signed because it has to be negative in your program, in your test cases. The represented value v should be preserved as much as possible. It would not be exactly the same, but it has to be preserved as much as you possibly can. In the following editor area, okay, which is like when you answer this question, it will give you this area. So what you need to do is to indicate what the mantissa is and also what the exp2 component is when your program is done with converting the number. So the way you can express this is just to say mantissa. This is just hand typed, okay? You don't have to copy and paste from the debugger. So you can say mantissa is 0x. You can use hexadecimal or decimal. In this case, C 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then exp2 is supposed to be negative 63. That will work for the example that I worked with. So yours is going to look uglier. Okay, your hexadecimal number here is going to be all over the place. Okay, but it's guaranteed to be at least 8 followed by all zeros. And then your exponent 2 is going to be negative, probably 80 something. That would be my guess. So do we know what to do, how to turn it in? Okay. All right, so I'm gonna stop the record. Yep, go ahead.
I had a question about the process series and the check. So you just take whatever mantissa value you have in GDB, convert it to hex, and then just try and work it out to make sure it's around the same number by basic math.
Yep, okay. But that's a sanity check. But to know whether it is exact or not, you have to send me an email, because then I can actually punch in the number and figure out whether it's going to be exactly the same or not. Okay. Any other questions? All right. If there are no additional questions, I'm going to stop OBS. So the streaming is going to stop.